Thank you, Elian. So how is everybody doing? So it's great to be here, to be honest. My first event as a Datadog employee was a summit back in Berlin in 2019. So it's great to be back and see all the faces and see all the conversations. So I hope you're learning a lot, talking to people, and also maybe behaving, because from the back, I was just realizing, I don't know if you noticed, that Batman is watching us under those M's in the logo. Actually, two Batman, so it's H.A. Batman, and you can say. And sorry to tell you this, because now you cannot unsee it. It's going to be H.A. Batman for the rest of the day. But today I'm going to be talking about Kubernetes. And many of you already know. How many of you are running Kubernetes today? So quite a few. Just in case you don't know, Kubernetes is a container orchestration platform that is going to help you run your containerized applications in production. And it's part of the Cloud Native Foundation, so completely open source, well-governed. And it's a very successful open source project. It's had 24 major releases in 2015, more than 100,000 commits coming from more than 3,000 contributors. So definitely super successful open source project. But what about, is it popular? So to test popularity for Kubernetes, this is Google Trend for the Kubernetes term searches. And Google Trend is a little bit special because it's basically a relative number. They come up with a number from 0 to 100 for the searches related to itself, so it's exponentially growth or not, and also related to other terms. So even though it's kind of weird thing to know, when I first saw this graph, I think there were two interesting things to see here. So the first thing is this change of trend. So, and I think this shows us something very important, is that it's no longer something hype. It's no longer part of the hype. It's not something that we all talk about and ask about. Should I do Kubernetes? What it is, etc. And it moved to a maturity level. So we are in the point that we use Kubernetes more, we talk about it less, because it's like kind of the Linux kernel. It's everywhere in the infrastructure, but you don't talk about it that much, depending on the abstraction layer where you are. So that's the first thing that I think is super interesting about this graph. The other thing that I noticed is that there are some outliers out there, if you notice as well. So one of the things that we love to do at Datadog is to put different data sources in the same timeline to try to find correlations and trying to find root causes. And we know correlation is not causation, but in many cases it's going to help us find the root cause. So I had an hypothesis about this, and I wanted to check if that hypothesis was correct. So I decided to put on the same graph Google Trends for Mariah Carey's Holiday Classic, All I Want for Christmas. And this is what happened. So it's perfect correlation. Obviously, the root cause is that it's a holiday season, people take time off work, and therefore they search less for work-related terms. If correlation meant causation, it would probably mean that a bunch of people once a year, we don't know why, they drop everything that they have to do with Kubernetes to listen to Mariah instead. That could be also the reason. So if you want to see all the trends, sorry, not involving Mariah, about container usage, you can check out our Datadog report based on our data. Good, so why did we choose Kubernetes in the first place? So Datadog has been around for 12 years, Kubernetes only for 7, so obviously we didn't start with Kubernetes, it was a migration. But when we wanted to move to containers, if you think about today, 2022, it's like the default. That's what we're saying, that Kubernetes is not the default way to run containers. But back then, we had to make a choice. It wasn't like the natural choice to do. But there were several things that we liked about Kubernetes. The first one is that Kubernetes is flexible and extensible. It's completely API-driven. So that makes it that you can build on top of Kubernetes very easily. The second thing was the large community. Obviously, we've seen 3,000 contributors. That's a lot of companies putting a lot of money and effort into making that project successful because they run their business on top. And the third was a business decision. We wanted to make Datadog the best platform to monitor Kubernetes. And a great way to do that is basically running ourselves, because we are going to run Kubernetes at a very large scale. So if we are able to monitor successfully Kubernetes using Datadog, other customers will be able to do as well. So how large? So to put an example, this is one of our clusters. If you're already using Datadog, you will know that this is the host map. So each of those hexagons represent a host, or in this case, a Kubernetes node. So pretty large cluster, and definitely it's not the only one. So we run thousands of clusters, many of them with more than 1,000 nodes. We run them in several clouds with the complexity that adds. And it's a platform that has to be used productively on a daily basis by more than 1,000 engineers. So pretty large Kubernetes. So the idea here is to give you some of the things, some of the decisions that we made over the years on how we run Kubernetes. And spoiler of alert, this is what I'm going to be talking about, Kubernetes. And it's very related as well when that maturity level of Kubernetes is becoming less the interface that every one of your developers is going to use, but it's more a platform that you're going to build on top. And to build that platform, you have to make some decisions. So probably you're not going to be using Kubernetes out of the box as it goes. So I'm going to explain some of the decisions that we made. It's not all of them, but we had to choose. So the first one I'm going to talk about is networking. So some of the decisions that we made about networking in our Kubernetes clusters, particularly on pod networking. And pod networking, a pod in Kubernetes, in case you don't know, it's a minimal deployable unit. It's one or more containers that share the same networking namespace. And pod networking in Kubernetes actually is basically two rules. Every pod is going to get a unique IP on your cluster, and you're going to have routable traffic between every pod in your cluster. The trick here is that this is actually not implemented by Kubernetes itself. There is an interface, part of the Cloud Native Foundation as well, called CNI, or Container Network Interface. And basically it's a definition. They define if you want to make an implementation of this networking, how you do it, and also how you can interact with other plugins. And there are actually many implementations of CNI plugins. And probably this is the first thing that you need to decide when you're building your clusters, what plugin to use, and what type of plugin to use, and how they work. One of the most common ways to do pod networking is through overlays. Overlays are good. It's like CNI plugins like Weave to networking overlays, for example. But if you scale, doing overlays is going to add an overhead to your network. So because we run these things on the cloud, we decided to use plugins that implement direct pod routing. And basically, those plugins that implement direct pod routing, what they do is that they use the underlying network of the cloud, your VPC where your cluster is running. And it's going to assign an IP on that VPC to each of those pods. And obviously, this has several advantages, also several problems as well as everything. But the advantages are clear, like you can delegate pod networking to the cloud. And also, you already have the two rules, like every pod is going to have a unique IP, and you're going to have routable traffic between all the pods. But also, you're going to have routable traffic between your pods and other type of compute that you may have in your VPC, like VMs or Lambdas, et cetera, which is great if you have a hybrid environment, but also if you're migrating to Kubernetes. But as I said, we're running on multiple clouds, and these type of plugins are very cloud-specific because they have to know how to get a network interface to the cloud, how to assign an IP, etc. So they are very, very cloud specific. So at the beginning, we were running different of these plugins for each of the clouds, which was working well. But about 3 years ago, we started looking at this project, a CNCF project called Cilium. And that was the early days of Cilium. But the goal of this project from the beginning was to create this full networking Kubernetes solution. So we started collaborating with that team very, very early on. We approached this project at the beginning because we wanted to have host-to-host encryption, and that was one of the things Cilium was offering. But as we started working with this team, also contributing a lot to the project as well, we started using Cilium more and more. And nowadays, we are using Cilium in our newest clusters as universal CNI plugin, because they do CNI as well with direct port routing on different clouds, which is great because we can just use one solution. But it also does all the things like network policies, service networking, and obviously host-to-host encryption, which was the reason why we approached the project in the first place. Again, we had to work a lot with that team to make it happen. And we are not considered to be maintainers of the project. So Laurent Bernet is one of our staff engineers in the compute team at Datadog. And he's going to give a session on the maintainer track for Cilium at KubeCon EU. So if you're going to be there, check out the session. So the maintainer tracks at KubeCon is basically every CNCF project run one or two of those to talk about roadmap and feedback, etc. So that was the first thing that we did. Another decision was developer experience. So as I said before, this was a migration from VMs, and our developers were very used to provision their own VMs and run their services there. And we wanted to make the transition to Kubernetes as smooth as possible for them, that they were used to do. So to try to mimic that, we decided that they were going to be able to provision their own VMs anyways, their own nodes. So we did that by extending the Kubernetes API, as I said, so that you can build abstractions on top, creating this new object called node group, similar to what EKS does, for example, but they can do it for any cloud. So basically, with a description of this, they can provision their own node groups, which are connected, by the way, with auto-scaling groups on every cloud. So that's super interesting. Once they have their node groups, they're able to deploy their workloads to those nodes with normal Kubernetes features like node selectors, affinity, etc. And as I said, this is connected to the autoscaler groups in the clouds. So we also run the Kubernetes cluster autoscaler. This is not ours. This is just part of Kubernetes. And the cluster autoscaler, what it allows you to do is that if they want to deploy a pod and that pod gets pending because it doesn't find enough resources in the node group, the cluster autoscaler is going to talk to the cloud provider autoscaling groups, and it's going to provision automatically a new node so that pod gets a schedule. So not only they're able to provision their own VMs, but also they know that it's going to horizontally scale as needed. So this was great at the beginning as a way to transition to Kubernetes, but this is not how you're supposed to do Kubernetes. You're supposed to share nodes between several services. So the next step was to start convincing those teams to share the same node groups for several services and to make sure that they were being packing correctly their resources. So basically, to request CPU and memory for the deployments in a way that it's similar to the actual usage. And this is a dashboard on the default Kubernetes integration in Datadog, which allows you to see whether your resource request is similar to the usage over time. To try to also reduce the cloud costs as well, we also do repacking on the cluster autoscaler. So basically, repacking feature of the cluster autoscaling tries to find pods that can be moved around to another node to free the node. So they will try to do that, and once they move it to another node, reschedule to another node, it will free the node that is empty. Obviously, all of this can be opt-out. Developers can decide whether they want their pod to be moved around or not. The next step is going to be this thing that we're working on right now, nodeless, similar to serverless. It's just a Kubernetes node, but the platform team is going to manage this node group instead of the developers. So we are encouraging teams now to say, if you feel confident, instead of provision your own node groups, you can pick one of the nodes that the platform team maintains, and it's going to be maintained for you, and just put it there. So particularly for stateless services, is what people are starting to move to nodeless. Cool. So that was self-service. So the third thing that I'm going to be talking about is policy enforcement. So once you've given your developers a lot of freedom and flexibility to run their things, you have to put some guardrails, because one of the things that happens when you scale not only Kubernetes, but you scale your teams, is that not everyone is going to be a Kubernetes expert, nor they have to be. Nobody can be a Kubernetes expert. So it's important that they're able to use the platform, understand the platform, but at the same time that making sure that they have the guardrails needed so they do what they're supposed to do. So how do we do that? We do that through admission controllers. So if you don't know what an admission controller is in Kubernetes, when you make an API request to the Kubernetes API server, it goes through 3 phases. First, authentication, so is this request authenticated or not? Then authorization, which is basically role-based access control in Kubernetes, which allows you to create rules of the type, can my user create a deployment in this particular namespace, for example. But once you can create deployment on that particular namespace, that's what RBAC does. So it goes through a third step, which is admission controllers. And admission controllers are small pieces of code, part of the API server, that go a little bit deeper into that API request and allows you to validate further that request, or even to mutate that request, so to modify it a little bit. So there are 2 special ones on the Kubernetes API server binary, which are validating admission webhook and mutating admission webhook, which basically allows you to create these pieces of code to validate and mutate without having to recompile the Kubernetes API server. And this is where the project that we are using, Gatekeeper, also part of the CNCF, attaches to the API server. So Gatekeeper is part of a bigger project called Open Policy Agent, and it has a specific language called Rigo. And using Rigo, you can create rules for your API requests. And to put examples of the type of requests that you can create with Gatekeeper and other admission controllers, is things like have all containers a specified set of resources, requests, and limits, if you want to make sure that those are being packed. Have the pod specification the needed security context, or are all containers non-privileged containers because we don't allow privileged containers to be run, or if the developer is requesting Linux capabilities on their container, are those part of this list that we allow? So thanks to putting Gatekeeper there, we are able to make sure that they still have that flexibility without causing any issues. So the conclusion, as I said at the beginning, is that Kubernetes is a platform. As your organization scales, not everyone is going to be a Kubernetes expert. You will need Kubernetes experts if you run Kubernetes, but not every single one of your developers is going to be able to be one. So things like low-level decision like networking needs to be done by your platform teams, your Kubernetes experts in your organization. You have to think about and design accordingly the developer experience. So basically, what type of Kubernetes interfaces you are going to expose to your users, what type of Kubernetes interfaces you prefer to hide to your users. And also remember to put some guardrails because, again, your developers are not going to be as expert as your platform team. So thanks very much. So if you want to discuss, have any question, want to discuss Kubernetes, bring your stories about Kubernetes, how it made your life easier or harder, join me and John on the Kubernetes Open Space at 4:15. So I'm going to pass the baton to John Kendall, part of the product team here at Datadog, and he's going to explain how Datadog can help tame some of that complexity that Kubernetes has. So thanks again.